Assalamualaikum. My name is Alif Alimi bin Juari. We are from 2 BMMA, section 1/1. Want to present about the free assignment BMMH 2313 that we need to conduct by ourselves. This is our team member that include 5 members. This is me. This is Faizul Fikri bin Hussein, Yumni Ruzaini bin Ahmad, Muhammad Haikal bin Muhammad Zainuddin, and Muhammad Hafizuddin bin Samsudin. This assignment is about two types of pipe configuration, which is straight line and closed loop configuration. This investigation is carried out to analyze the pressure variation in hose pipe with specific length of pipe by performing experimental and simulation using ANSYS flow exercise in hose pipe. Various tasks were done to justify the maximum flow rate, velocity, and maximum achievable water jet. Also maximum pressure in pipe. We use ANSYS to get the theoretical measurement for these two type of configuration. Objective. The objective for this assignment is to perform experimental and simulation flow exercise in hose pipe. Then we want to analyze pressure variation in hose pipe over a specific pipe length with straight line and closed loop configuration. Then we need to report the finding in an appropriate approach. This is the list of equipment that we use in this experiment. There, there are 16 millimeter water hose pipe, 16 millimeter 3 connector, 16 millimeter single connector, hose clip, measurement beaker, and stopwatch. That's all from me. I will pass it to another presenter. Thank you.
Assalamualaikum to lecturers. My name is Muhammad Haikal BMMH Zainuddin. My metric numbers is B0921104118. Today I'm going to present about work process of this experiment. Okay, first of all, prepare all the equipment that will be used during the experiment. The equipment from previous slide will be used to complete this experiment. Second, we prepare the equipment to make the straight water hose configuration as shown in the assignment sheet. Next, then cut the water hose of 16 mm times 10 m into 5 meter using scissor because we bought from the shop that is too the length is too long. After that, we make 5 holes on the hose that equal to 100 cm between each of them. Next, block the end of the pipe using hose clip and hand grip. We open the tap out to maximum and measure the flow rate or velocity at each hole in same volume. Record the data properly. We use a stopwatch and a beaker to record the data by using the information that have been given As we can see, this slide is about straight line water hose configuration. So for the next experiment, which is closed loop water hose configuration, by using remaining hose and 3 hose connector, 16 mm triple connector to make it loop in circle, then make 4 hole in equal distance on the same level, tap in maximum level and measure the flow rate or velocity. Lastly, record the data. That's all from me. Thank you.
My name is Muhammad Afizuddin, Prince student. So I will talk about simulation for ANSYS 16 data. So in this simulation, we make two type of different simulation. The first one is for water hose straight line, and the second one is for the closed loop water hose configuration. Okay, for the straight line water hose configuration, we get inlet pressure and outlet pressure. After that, we get inlet velocity. We get inlet density and outlet density. For closed loop water configuration, we get the inlet pressure, outlet pressure. After that, we get inlet velocity and density and outlet density. Okay, that's all for me.
Tiga.
Kau buat apa tu?
20 lah.
Lepas tu kau lepas kan? Kau lepas, cuba kau lepas. Kau boleh ambil lubika. Nampak takkan mana saya tu? Nampak? Okey, stop. Kan. Satu, dua, tiga, empat, lima. Okay. Habis.
Kenapa ini lambat ni?
Tak apa. Tak apa-apa. Okay, please.
Okay, next task 1, maximum water jet is equal to 0.027 and maximum pressure in pipe is equal to 1589.4 Pascal.
Okay, next, the maximum pressure in pipe, we can actually got it from Bernoulli equation, which we can simplify to P1 equal to P2 plus Z2 rho G. And from this slide also, we can see that to calculate velocity, we can use formula V equal to OQ divided by pi d square. Okay, next, from this slide, we can see that for straight line water hose, we use 5 hole, and when the water reach 0.1 volume, the time will be taken. And after that, we will calculate the flow rate by using formula meter square over time. And from this one, we can see that the volume must be divided by 1000 so that it can become meter square, and then we will divide it with time. And for the velocity, we can use the formula V equal to 4Q divided by pi d square, where the Q is equal to the flow rate and the D is 60 millimeter, but we must convert it to meter, which we must divide it by 1000 also. Okay, next, from this slide, we can also see for closed loop water hose, we also using 5 hole, and each hole will have time taken. And for the flow rate, we using the same formula as straight water line hose, which is meter cube over time, where the volume must be divided by 1000. And for the velocity, we also using the same formula with straight line water hose, which is V equal to 4Q divided by pi d square, where the Q is equal to flow rate and the D is 16 millimeter, but must be converted to meter.
So next I will explain about the discussion of this experiment. Firstly, if the flow rate water increase, the time taken for water to fill up the jug will decrease too. This means that as the water flow rate increase, it will take less time to fill the jug. When the area of the pipe connector decrease in experiment 1 and 2, the water flow rate decrease due to energy loss, minor and major loss, resulting decreased rate in pressure effectively flow rate of fluid. So the conclusion is we are able to perform this experiment flow in the hose pipe successfully, and then our group also able to deduct the pressure in the pipe and the velocity of water flow in each and every hole on the hose pipe in any configuration given by identifying the flow rate of the water. In this experiment, our team member also investigate and summarize that the pressure and the velocity are directly proportional to the velocity. The higher the pressure, the faster the velocity. That's all from me. Thank you.